deep.
Wow.
Which doesn't really match up with a lot of the stuff that we get from these skyquakes.
So this
they
could be
don't,
an outlier.
Yeah, I think it is. But there's a lot of fantastical stuff that goes on with the story of Bell Island, but we're going to leave most of that behind.
Okay.
Because what we want to do is we want to focus on this electromagnetic pulse theory part.
Okay.
According to the theory that this is some government body that's responsible for this, and a lot of stuff will point to, well, it was the Americans or it was the Russians. You've got to kind of take a look at what happened at the time with this and why they think it's an electromagnetic pulse. One of the things is that with an EMP, there's no radiation. Typically, there's no touchdown point, like these holes in the ground.
But by radiation, you mean there's no...
like atomic radiation. You just set off an A-bomb.
There's no really high-frequency radiation.
Yes, there's no fallout.
EMP works through radiation.
Yes, but you know what I'm saying.
It's not about
it's
radioactive...
not Hiroshima.
Yeah, the kind of stuff that gets into your blood and kills you.
Correct.
Okay.
Yeah, that's where I'm getting at.
Okay.
And so, of course, all the electronics is fried and hosed, and you can't use your iPhone. Well, people say that this must have been an experiment by a government body, and one of the and again, this is a government body whether they did it intentionally or not. So nobody says whether they were nefariously targeting Bell Island or just accidentally touched down there. What adds a ton of fuel to the fire, though, is the fact that two scientists from the Los Alamos National Laboratory came to Bell Island to investigate. Now, you might
What were their names?
I didn't write down their names, and that's my bad. But you might recognize the name Los Alamos National Laboratory because they're the ones who were involved in the development of the first A-bomb.
Yeah.
So people point to that as, oh, well, those guys at that terrible place that did this must have done that.
Yeah, maybe.
20-some years later, 30-some years later.
Working on the next kind of big leap in warfare. Maybe. I mean...
Yeah, I mean, it's possible. I mean, the whole EMP effect of atomic and nuclear weapons was known back in those days. As far as building a really teeny little nuke that was just tuned so that it would just have more than just emit radiation, so than explosive force and all that would, like maybe they were working on something like that at the time. I don't know.
And I've also seen in some stuff that I've read, and this was more, fictional accountings. There is the fact that you can detonate a nuke several miles up, and the radiation won't hurt people like it would when it detonates on the ground, but the electromagnetic pulse will still affect electronics.
Yeah.
So theoretically, there's the idea that they were testing something high in the atmosphere, and something fell, or, there's people who say it's some kind of lightning. Because in the reports of Bell Island, they talk about some giant, bright bolt that was quote-unquote seen from space. I've never seen that picture, by the way.
Yeah, I mean, I guess I think it's a fair theory to think that, if they were going to test something like this, right, they would probably be testing it over open water instead of over land.
That makes total sense.
They accidentally detonated it
too close
to land and too close down low, so it actually did fry a bunch of stuff. It landed with some debris. I guess I can kind of get behind. I mean, obviously, it's not my favorite, but I also can't talk my way into this theory, so.
I can talk my way out of this way faster than I can talk myself into.
Fair. The problem with this is an explanation for skyquakes is it's only one incident.
And it's very new.
Yeah, and
right?
so...
Yes.
But I am willing to say that it could be a good explanation for Bell Island specifically.
Maybe.
I could see some credence there. Let's move to the next theory, though. We've got meteors.
Yeah.
Huh.
This one's actually really pretty straightforward, and the idea is that people say that what they're hearing is the sound of the sonic boom caused by a meteor entering the atmosphere. Well, it turns out that evidently, typically, a meteor, when it hits the atmosphere and it starts to burn up, this happens 100 kilometers or about 60 miles above the Earth's surface, because sound travels slower than light. People might see a shooting star and then minutes later hear the boom, and so they wouldn't recognize it. And if it's at daytime, they're not going to notice this bright spot in the sky. That kind of makes sense. Evidently, it takes about, from that distance up, it takes about 5 minutes for sound to reach from 60 miles up to the surface, down to the surface of the Earth. So there's some scientific credence to that.
It doesn't explain why it's only coastal regions, though.
Exactly.
It doesn't.
Yeah.
You're absolutely right. And this occurrence of meteors making noise, this is what is evidently referred to as electrophonic meteors.
Okay.
In other words, a meteor that is heard.
Yeah, well, like the one that exploded, they basically heat up and then explode and disintegrate and create a huge boom.
Well, and that's the issue, is that if it was meteors that were hitting and exploding, even if they're not big ones, you would think that we would find some kind of debris on a more regular basis than we do.
Unless they're hitting the water.
That's
or
true.
burning up,
But yeah, the thing about it
floating
is
in the atmosphere, and then it's just lots of little particles.
yeah, but the thing about it is that large meteors that explode like that and make a big noise, they're kind of rare. Mm-hmm. And
Yeah.
And also, like, we have a lot of scientists. I'm pretty sure that somebody would be like, oh, hey, because they track it. When things, like, hit the atmosphere, they track that stuff. So, like, it would be pretty unreasonable to think that, like, if this is such a widespread phenomenon, that somebody wasn't like, oh, you know what I'll do is I'll look at all of the, like, pretty large meteors that are capable of making the sound and see if they, like, correlate or not, because that would have happened.
Yeah. Now, the one thing that I do think about that, the issue that we had is, well, this happens kind of around coastal areas. There's one thing that you do have to remember, which is the air above the ocean tends to be cooler than the air above land. So it could be that they're hitting that cold air front, and because they're so hot, they're hitting that blast of cold air, and that might be causing them to actually shatter and explode rather than just to continue to burn up as they're going through warmer air. Does that make sense?
No.
Would it be almost like hitting a wall of ice cold
I'm
air?
hearing what you're saying, but I don't think the science follows.
Yeah.
Okay. No, this is just, again, I was like, oh, well, it is
Right.
colder air. That could be an explanation.
Yeah.
But
Yeah.
I don't think so.
No.
I think that, no.
next we have, and this one I really find funny.
Because you're a boy.
Yeah, I do. It's gas venting or burping.
Farts.
Yeah.
Earth farts.
It's earth farts.
Earth
It's
farts,
exactly-
yes.
Which is why you think it's hilarious.
I
Yeah.
am 12 years old.
Yeah, well.
Again, this does actually kind of explain possibly why this is in coastal areas.
Yeah.
What it is the idea is that methane gas is trapped underneath a lake or underneath the ocean, and this is caused from the breakdown of organic materials, whether they be plants or animals, and then at some point they seep upward and they come up in a great explosion out of the water.
But why would they explode versus just like bubbling up and leaking into the atmosphere?
Like a fart.
Yeah,
Yeah,
somebody's got to be there to light
Somebody's
it.
got to be there with a
Yeah.
bic.
Yeah, that's the problem, is that if it was gas, I mean, that would be a huge amount of gas to, let's ignore the explosion for a second.
Sure.
That would be a huge amount of gas to cause such a giant bubble that it makes that concussive blast as it just breaks the surface of the water, and then the water collapses back into place.
Yeah, you'd be seeing a lot more dead aquatic life,
Yeah.
probably.
Okay, and if it is an explosion, okay, what's causing that explosion, and why haven't there been reports of flames of any kind around the Skyquake issues?
Yeah.
Yeah, and the thing about it is like when methane or oil or whatever leaks up from the ocean bottom or wherever, it just sort of seeps. It doesn't usually come up in
No, it doesn't come out in one gigantic outflowing.
No.
I'm trying really hard to not make all the fart jokes.
The next theory is actually really closely related to the methane gas, which this actually is a theory that there's a rapid, just oxygen, but a rapid air release from the collapse of underwater caves. And again, this one kind of says, well, it's the noise from the cave collapsing and the air rushing out and all the debris underwater falling. But I personally, That's a lot of caves collapsing underwater if that were the case.
Yeah, the thing about it is caves tend to be pretty stable. They've been there for millions of years.
Yeah, eons.
Yeah, I know. That's why I feel I used to do a little caving. And if I'm in a natural limestone cave, I feel far safer than I would feel like if I were in a tunnel, like the highway tunnel, for example.
Yeah, absolutely.
In an earthquake or something like that, because I mean this thing has been through all kinds of earthquakes.
Yep.
Yeah.
And so
also, underwater caves typically don't have that much air.
Usually they're filled with water.
Usually, I mean, sometimes they have like a little bit of like air at the top or whatever, but.
And so if it collapses, the air doesn't all get out at once. A lot of debris comes down, and the air sort of fizzles out between all the debris.
Yeah. It's like soda.
So I think the
perfect description.
Carbonate.
Yeah, exactly. It would sound like soda. So I think cave collapsing is a bad thing. Yeah.
Yep.
Alka-Seltzer.
The next
flop flop fizz fizz.
Yeah.
The next one that we have here, I kind of like this one.
This is plausible.
And this is that these sounds are caused by earthquakes.
Sure.
And there's a bit of science that we need to go into to help flesh this out.
I'm seeing words like S wave and P wave and
and I actually abbreviated a bunch of big sciencey words. Okay. Earthquakes cause seismic waves, which are low-frequency energy waves that travel through the surface of the Earth.
Sure.
Now, seismologists, those are guys who study earthquakes.
They study sizes, don't they?
No. They measure the seismic waves. Use that twice in one sentence. And they, that's how they determine how strong an earthquake is. So that's when you hear the Richter scale, is what we hear a lot to determine or to describe the strength of an earthquake. Okay, and most people are probably pretty familiar with that description. Here's where it gets a little trickier, is that the seismic waves are composed of actually two different kinds of waves. We've got a P wave and an S wave. And the P wave typically will be described as, the name is primary wave, and S wave is secondary wave. The P wave is faster, so it also is a compressional wave. Now, what that means is that it compresses and expands material in the same direction that it's moving. So if you think of a slinky that's laying on the floor sideways and you shook it, how it travels back and forth horizontally.
Yeah, so the P wave is the one that shakes your house from side to side and causes it to fall off its foundation.
Somewhat, yes.
Correct, yeah. Okay.
Yeah, somewhat, yes. And then we've got the S wave, and that's the slower of the two, so it's the one that shows up second, because they don't always show up at the same time. That's why you can have a difference in an earthquake can hit in stages.
And aftershocks.
Aftershocks, yeah. And the S wave is responsible for actually shaking the ground up and down, as well as side to side in the opposite direction of the P wave. So if the P wave is going directly in front of you, the S wave will make the ground heave up and down and left and right of where you're viewing.
I see. Yeah, it's I think the P waves are what they measure often for like the pre-shocks. Because you can
sense them ahead of time, because that's the one that's easier. You can hear it coming.
Yeah.
Well, that's actually a perfect segue, because it turns out the P wave is the one that is making and carrying a lot of the sound that is heard when earthquakes happen. So the theory goes that really low magnitude earthquakes, so we're talking on the Richter scale anywhere between 1.0 to 3.0, so these are very small, you can't really feel them, and especially if they're really deep, by the time the wave reaches the surface of the earth, its shaking power is gone for the most part, but the sound is still traveling with it, and so that sound is released, and that's what we hear.
So is this the surface of the earth basically acting like a gigantic speaker, vibrating and creating sound waves? And
it's rock, so the sound travels through it, and some material obviously will allow the transmission of sound better than others. I believe, correct me if I'm wrong here, guys, coastal areas are usually rich in things like limestone. Is that correct?
No.
Is that not correct?
I don't know if they're any more rich than anywhere else.
Okay.
I mean,
they are rich in tectonic plates.
Well, but what I'm looking at is I'm looking at
go.
coastal areas usually are composed of the same generally, and this is a very general statement, kind of rock compared to what you would find in, say, the center of this country or continent. And I'm thinking that maybe part of this is that if it's a less dense rock, that sound can travel easier and not dissipate. I don't know. I might be screwing up that part of the science, but there is actually a recorded episode of a lot of booming sounds from low magnitude earthquakes in Spokane, Washington back in 2001. And a series of booming sounds were heard, and they figured out that there were a series of very, very small earthquakes that happened, and they were actually really close to the Earth's surface. So the sound came through, but because they were so weak, they didn't have a lot of power to shake things up, no pun intended.
Yeah.
So that's an idea that it's some kind of seismic activity.
Yeah, it's a possibility.
I mean, yeah, it does make sense. Coastal regions are, they have more earthquakes often because that's where the tectonic plates are like really coming together. It's like very often where like the shelves, that's where you get the
upheaval and the underflows.
I don't know. I mean, I guess it makes sense, but also on the same token, like they track that stuff pretty heavily. I mean, the fact that they could track that there were earthquakes in Spokane that caused those booms would make me think that if it was the cause of all of the other ones, that they would be able to track that there were also things there.
The problem is that those low magnitude earthquakes are really hard to pick out from the background noise of everything else that is going on in the surface of the earth. I mean, we make, as people, a ton of noise. Think about all of a freeway. And then try and think about when you're trying to get recordings out of the ground for earthquakes, and all you hear is cars driving by. We create tons of vibrations, and we create tons of noise, plus the ocean makes a ton of noise.
That's fair.
So those low magnitudes ones, they have a really hard time picking out the small ones from just all the other jumble of noise that's going on at the same time.
Fair, yeah.
I agree.
We've got another one here, which... I'm sorry, I'm going to discount this right away, and I don't mean to poo-poo this, but the theory is military testing. And this is a lot like the Bell Island one. People are saying, well, the military is doing things, and they're not telling us about it, and that's causing these noises. But my issue is, again, the longevity of the booms being recorded versus when we had the capability to make this kind of sound.
Well,
Yeah,
exactly.
I mean-
Same as sonic booms. It's like, I really think that these things are probably caused by a whole lot of different causes. Probably some of them are sonic booms. Some of them are artillery or explosions of people mining dynamite, using dynamite to blast out quarries. Yeah.
But I know that this can't be what caused this when the original natives of this country, the U.S., heard this noise.
Yeah.
I know it was not the U.S. military setting off some secret weapon.
No, and there weren't a bunch of white people over there doing some mining, because they weren't here, So,
So
not military testing, not people with
okay, it could account for a very, very teeny percentage, but that's all I'll give it. Next we have, and this is actually a theory that really only comes up in one area, but that is the continental shelf falling off, which is actually something that only happens in the South Atlantic. This theory only comes from the South Atlantic region of the United States. And what it says in its simplest form is that we've got tectonic plates that are heaving over each other and diving under, and that the continental shelf is essentially sloughing off and breaking off as it's, being pushed under.
I don't like it. No, I don't like it. I mean, anything that would create that kind of clear noise would also be creating huge tsunamis and, a lot of other stuff.
And we're not seeing lots of tsunamis.
Also, the continental shelf isn't falling off in the middle of Lake Michigan, for instance.
Well, there might be like a little Michigan shelf that's falling off.
That's probably true.
Hey.
The little Michigan shelf.
Yeah, the little Michigan.
Yeah. Well,
Okay.
any other theories?
Yeah, absolutely. And I got to tell you, this one that we're about to go into is probably my favorite theory, and that is that this is caused by meteorological events.
That's a mouthful of a word.
It is, though the folks at home don't know what I said it 7 times before I got it right.
That's what happens when you're the editor.
Yeah, it really is. Here's what's going on. And this is based on what's called inversion or atmospheric inversion. Heat rises. Mm-hmm. We know that. So as heat rises, it warms the air. So the air at the surface of the Earth is warmer, and as it goes up, it cools until we get to the top of the atmosphere.
Right.
Out in the ocean, this would hold true unless we get an upwelling of cold water, because currents cause upwells, and so they push tons and tons of cold water towards the surface, and that can cool that air in that region. So if you think about the way the air is, and let's just break this down into 3 layers from the surface of the Earth. So we've got the bottom layer, the middle layer, which is slightly cooler, and the top layer that goes to the edge of our atmosphere, that's the coldest. You with me so far?
Yeah.
Okay, now, if we get a cold air inversion because of that, that cold air pushes up as it comes inland. It kind of pushes itself a bit above, and we get a cold, warm, cold. So it's cold air on the bottom, warmer air in the middle, and then colder air on the top, and it kind of creates a air shelf.
Okay.
What happens is sound travels typically farther in a cold environment. So if we have this happen, and out at sea, several miles out at sea, there's a thunderstorm. People in the area are going, wow, it's kind of a cold day. It's clear blue skies, but it's chilly, because they don't realize that, let's say 20 miles up, the air is actually warmer than where they're at, or it's warmer than it should be. Then we've got a storm out at sea, and it's a thunderstorm. That sound from the thunder is going to ricochet.
Oh, it goes through a cold air tunnel.
It goes through a cold air. It hits the surface of the water. It bounces up. It hits that kind of shelf barrier between the cold low area and the warm middle area, and bounces back down to the earth. It's kind of like skipping that we talked about with Lost Boy Larry, with how radio frequencies skip.
Yeah, it's actually a phenomenon that they experience with sonar and undersea.
Yeah,
so you get, because thermal layers, a thermal layer, which is a temperature gradient, sudden change. Low frequency sounds can travel hundreds of miles. So so that bounces back and forth.
Right, and so that thunder would bounce back and forth, the sound of the thunder, and so it comes inland where it's a beautiful blue sky day, and there's this sudden crack and raging noise, which, if you think about that clip that we played, kind of sounds like thunder.
Yeah, I guess the only problem I would have with this is that it seems like the sound would kind of deteriorate over and I don't know if that's true or not. I don't know if it does or not, but I lived in the Midwest for a little while, and they have some pretty rip-roaring thunderstorms out there. And still, I don't know that I have ever heard thunder that is like that percussive that sets car alarms off like crazy. I mean, yeah, every once in a while, but for it to be coming from like 20 miles away out to sea or whatever, be traveling to still be that percussive, to be like that powerful, seems counterintuitive to me. And I don't totally, I'm not a scientist, I don't have the science behind it, but it seems like at least the percussive quality of it would deteriorate a little bit, that it wouldn't be.
Well, have you ever been in your house and the thunderstorm is directly above you and it's rattling the windows?
Yeah,
or if you've been on a mountain, so you're high up and a giant thunderclap goes off, it's friggin' loud.
Yeah, but
and it rattles the hell out of it.
I don't know if it sets off car alarms like that, or if it that was all the car alarms.
I would say that
right.
It was.
If you're at ground zero in a lightning storm, which I have been in. The boom is tremendous, and that was set off. But again, from a distance, it's hard to say. Yes, it really is. I mean, that video that we saw we heard the car alarms going off. But the guy that was making the video, maybe he and his friends were throwing rocks at all the cars in the neighborhood to make them go off.
And the dogs, so the dogs were barking.
Yeah.
Yeah, the other thing is that when we listened to that video earlier, and we keep talking about this, like, I don't know that it'd be that percussive. It's also, I don't know, it doesn't really sound like thunder to me.
Well,
it sounds...
interestingly, if you listen to the two blasts that you hear, they're remarkably consistent. It's basically three quick explosions.
Yeah, and thunder is usually like...
It's a little more random.
Did that go, Devin?
No.
Yeah. Of course, this particular video, I mean, it isn't necessarily one of these sky booms or whatever we're calling them.
Skyquake?
Skyquakes, yeah.
Sky boom, I like it.
Sky boom. And what it sounded to me like, it was three quick explosions. It sounded to me like an M16 with a 3-round burst selector activated.
I mean, it does sound like a gun.
Very specific. No, I mean, it could sound... I mean, I've lived in rural areas where they were setting off explosives, and it does kind of sound like an explosion, literally like an explosive detonating.
Yeah.
So, that could be an explanation, and that would explain why the sound is so loud and so clear. But again, the problem is, why is it only in these areas? I mean, are they doing something off the coast with explosives that people don't realize?
Possible.
There's explosions going on everywhere. But yeah, again, this one sounded to me like a 3-round burst from an M16.
And it's possible that the other ones sound different, but it's hard to tell.
We've only got there's a number of videos out there that you can track down.
Good.
I mean, I only pulled one in, and the problem is that they're all outside with the wind and the dogs and the cars, and it's a cell phone or a video camera, so it's hard to get that noise very clear and exact.
Yeah.
Yeah. Well, I mean, and these things, most often when they happen, you just get a single boom, right?
Not always.
You run outside.
I mean, there's multiples like what I've read about, several in a row. So it's not as if it's, like I said in the beginning, it's not always just one. It can be several of them.
That kind of lends
I don't know.
Yeah, it kind of lends credence to the whole theory that it's a thunderstorm far away, that the sound's just being channeled.
Yeah, and that's honestly
that's we talked about.
That's my favorite one. That the last theory that we've got, I'm even worse on than the military testing. Is people say, well, it was a gun, like Joe just said. Oh, it was somebody was shooting a gun.
Somebody was shooting a big gun.
Handguns, long guns, big guns. There's still the problem of time.
Yeah.
We haven't always been able to make that loud of a concussive sound, so that to me seems too simple, and I kind of let it go right after reading about it.
I think that's fair.
Yeah, no, it is. I think that again, as I said earlier, I think it's these things probably come from a multiple set of sources, and I'm liking the.
I agree with you.
I'm liking the whole idea of the sound channel being converted by the inversion layer, and then it's being sort of funneled towards the coastline from a distant storm. That probably is responsible for some of that.
And I also agree that it's that, and I think part of it probably is, the earthquake theory. There are small, minor earthquakes that channel that sound, and I think that's possibly some of it as well. Now, why it's only heard in coastal regions, that's not really explained very well in this, but that's the other one that I kind of give stock to.
Yeah, and then there could be a couple of occasional random ones. Could be meteors, could be sonic booms. Maybe.
Yeah. Yeah, no, I think a nice mix of all of the theories is probably the best explanation for this one.
Yeah. Sweet.
Yeah.
All right. Well, that is the theories that we've got. I think we've kind of all weighed in enough on that. I don't think we need to beat that anymore. If you have any thoughts of your own, you can always tell us about them. You could send us an email. The email address is thinkingsidewayspodcast@gmail.com. If you want to watch the video that we listen to in the show or read any of the other research links, those will be on the website. The website is thinkingsidewayspodcast.com. We also have the shows available there for listening, but a lot of folks are doing it through iTunes. So if you're on iTunes, take the time, subscribe, leave a comment, leave a rating. And if you want to stream us because it's just easier for you, you can always find us on Stitcher or TuneIn. Those are two easy spots to stream the show. We are on Twitter, so it's Thinking Sideways is us. And
we dropped a G.
We dropped a G.
To be more hip.
We wanted to fit into with today's new crowd.
We dropped a G, yo. So we're also on Facebook. We have the group and we have the Facebook page.